All right, so here we are back again with making these connector shells out of this 321 stainless that was so nasty last time. So the way I made them last time and the time before was to use the lathe, because drilling a hole through the center seemed like a natural for the lathe. And these are made out of 321 stainless steel. So the drilling aspect of it was the most miserable part, because 321 stainless steel is so gummy that if you didn't put constant pressure and pull back quickly, you'd turn up a partial chip that was attached inside. When your drill bit went back inside, it was liable to break it. And I did break a carbide drill bit in one of the parts last time, a brand new one that I just bought. And it was cutting fine until I did that, but this stuff is really tough to deal with. So I was thinking, no point in showing you doing a lathe exercise again, but I thought perhaps I should make these guys on the mill instead. Now you think, oh, the mill's not as ideal for this because it doesn't hold the round stock as well. Finding centering for the hole down the center isn't automatic like it is on the lathe, and all that's true. But one thing the mill has over the lathe is that I have the wheel on the quill for drilling, which will make this much easier for plunging in and out, which I had to do, because on the lathe, you're using your tailstock and you're cranking it in, then cranking it out, cranking it in, cranking it out. And you can loosen the tailstock on the table and slide the tailstock out and crank in, slide the tailstock out, crank in. But all in all, it's a lot more difficult, I think. So what I'm going to try is a whole approach doing this on the mill, and rather than parting these parts off, I'm going to cut them off on the bandsaw. And I'm going to make a fixture to do that so that I can make these 0.78 parts. So basically what I'm going to do is we're going to cut off a section longer than 0.78, call it 0.8 at least, maybe a little more. And we're going to take all these little pieces over to the mill, and we will face one side to make it flat, flip it around in the fixture, face the other side to length on all the parts, then drill a hole down the center. And what I might do is drill the hole down the center first before I face either side. That way when I do the facing cuts, it'll clean off the swarf. Because the other thing is I had to deburr all these, and I deburred all these by hand, and it was really tough because, again, this material's gooey. So when you're taking your deburring tool on it, a lot of times it just smears the metal around, leaving still a ridge. So it was a big pain. If I get a chance, I'll show you. This is part of a jet engine temperature sensing apparatus. It's a pretty complicated looking thing. They use a bunch of these in there, and these are the connector end, and these get welded on, TIG welded on to an end for hermetically sealed and filled with a spherulite mixture on the inside that's still a little bit flexible that will keep the wires running centered down through the range of the whole assembly. And it's really kind of fascinating. I don't know how much I can share with you details. Actually, I don't know a whole lot of details myself, but some of it might be proprietary, so I got to ask the vendor if they let me share that with you. But pretty cool. See, there's a very big deal here on deburr the inner diameter. That was such a pain last time. I'm hoping to have a better solution this time. This slot will become more clear later, but basically what's going to happen is the 1/2-inch rod is going to go all the way through this length out this side here. I'm going to put this in the bandsaw. I'm going to cut off just the end of this. That gives a saw stop behind it so that I don't hit my fence when I cut through. And the material is going to go down the center of this. So that's what I'm drilling now. We're going to start with a smaller drill bit. We're going to work our way up to 1/64 under 1/2 inch. Then we're going to ream for 1/2 inch. And then I'm going to put a drill and tap a hole on the top for a something to tighten down on the shaft to hold it in place while we're cutting it. And hopefully we can just push these through and, you know, very quickly cut out all the ones we need. And I let the slot go deeper because in case I screw up or take this fixture out, I want the saw blade to be supported by the aluminum right up to the edge. That way I'm hoping for fewer burrs. That may be a mistake, but we're going to give it a shot, right? Okay. Huh. I have never had the nut come off before, but I bought this nut aftermarket, and because the bearing ones you could make tighter, which it definitely did, but now I've got to figure out how to get it out. I am a little confused what happened. I mean, I snapped this guy in like I did on the other one, and it was problematic. All right, we're just going to drill this guy out to 1/64 under. Next up, reaming. I'm going to drill and tap for this thumb screw. It's a metric thumb screw, M6. And we should be good. And this fixture should be done until I take it over, mount it, and do my first pass and cut right through this section here on the end. And then each time I remount this fixture, I'm figuring maybe I have to make these parts again because they seem to like them. I've had to make them for them in the past, as you've probably seen. And so anyways, if this solution works, which I don't know that it will be faster or easier, I'll continue with it. You know, otherwise we'll try something else in the future, but I guess that's where we are now. I changed my mind. I wanted to add a second option here. I want to do a 1/4-20 set screw with a plastic plastic piece inserted to press on the material. So I'm actually going to come this direction because that way I can get closer where you clamp down, so I can possibly get one more piece out of the part, out of the material. Otherwise I'm going to waste the end piece. Now we're good, so I can switch to the thumb screw if I want, but I also have the option of the set screw, which I think I'm going to start with because I can use a long handled Allen to reach down. I think it'll be ideal. All right, so here's the fixture loaded in the bandsaw. So the rods will come in from the back, and I need to get a work stop here. So historically what I've used is these really inexpensive mag bases because they have two perpendicular sides, but I always end up wanting to use this side or the other side, and they're not flat. So what I did was took one over the surface grinder and ground them flat, both sides, so that now I can set this up here as a work stop. But before I do any of this, I need to cut right through this material because the whole point is I want the saw blade as flush to this guy as possible so that there's less likelihood of ending up with material squeezing out because this stuff's so gooey. So the first step is just going to be to cut this end bit off here, and the slice here goes deeper so that in the future I can run the blade against it again. That should be enough. The extra material behind it is so I have a stop for the blade. Now I need to set this space so when it cuts off flush, this piece will be a little bit longer than I need so I can finish both sides, and we'll see how that works out. All right, to set this guy up, I'm going to put this 0.9-inch gauge block here, slide this guy over. This is not a critical measurement as long as it's got extra. Lock that guy on, and then remove my 1, 2, 3 block, and hopefully we'll get some repeatable results. Trying to get the camera in here so you can see is proving to be exceptionally difficult. So we're going to push a piece out like this. It stops gently, like there. Then I just tighten with the Allen wrench. And then I cut it off, which now I need to slow my saw speed down quite a bit. Whew. It just barely misses the camera. Now this should just graze where it cut already. The only mistake I made is I measured off this face 0.9, and that didn't include saw blade thickness. Well, maybe not enough. I got to measure this and see what we're actually at. So there's a little bit of a burr left on the material itself, and I don't know if you can see this, but the material itself that's left in there, yeah, it has a little bit of a burr too. So we're gonna have to leave some more. I think we're gonna have to move this over some. I don't think I left enough material, but that's why we're doing this. So actually the length of this part, I needed 0.780 final, and I would have liked, maybe 10, 20 thousandths aside to remove. It turns out this is 850, that leaves me 70 thousandths. Now this next one, you notice it's not sitting up flush against the stop. So that means it's going to be shorter still, but it might still be okay. So I'm going to try and cut this off and find out. So I took some weight off at the end of the cut this time just to see if I could improve it. Let's see what my distance is. We're actually good, but you see what I mean about gooey? Look at that, it just smears the metal right over the end. So this is the one I took some weight off at the end of the cut. There's still some of the crap smeared, some of the metal smeared here, but not as bad as before. So I think we're good. We can proceed. Finish one cut, spin this out. Get it as close as you can to the stop. Let the blade come in. Now the blade's at the thickest part of the cut and it's starting to get thinner. I put some weight on the saw to remove weight off the cutting force and sort of let it feather its way to cutting the very end there to minimize the burr. Next up, so I can drill down the center of this, I also want to be able to set depth accurately, which means I need a stop. So this is a Edge Technology cullet stop, but I don't think, well, I don't want to damage the ones I've got, so they're steel. So out of aluminum, 7075 aluminum, I'm going to make a 5C stop that will fit up in the 1/2-inch bore that when I drill down the center of, I can drill into, and hopefully, again, that'll reduce the number of burrs I create. I'm not sure, but I'm hoping. So this is a pretty snug fit. So I'm just going to create the solid stop for this, and I'm going to make it out of aluminum, 7075, so it's strong. We're going to need to put this with tailstock, with a center on the tailstock, so oops, looks like I did not get that tight enough in the collet. Can't get in far enough with this insert without hitting the center. So we're going to use this one instead. It's got much better reach. Gonna make that a little undersized. Oh, wow. Look at that. I think I just bent the part. No shit. Okay, I've never tried parting with that before, but I believe I just bent the part. Oh. Well, it survived. I'm surprised. It actually was revolving around the nib. I've never tried that before, and I guess I won't be doing that again either. Parting tool got broken off and was wedged in there. I actually thought I'd scrap the part, but I did not. the part I got to remove that pip, although I'm going to be drilling straight through there. This way, hopefully it will prevent a burr. Now, making this out of steel would have been better, but I didn't know if it was necessary, so we're going to try this and see if it works. All right, so now at the next step here, we've got a decision to make. What's the order of process to do this? And it's a big deal because if I choose the wrong one, it's going to be a lot more work. And since there's a lot of parts, as you can see over there, that means a lot more time. So, you know, it multiplies. If you got 10 seconds by 1,000 parts, that's 10,000 seconds. That ends up being a lot of time. Now, I don't have anywhere near that many parts. I've got like 40 or 50, but still, it matters to some degree. So here's the deal. I had to deburr both sides just so it would fit in the 5C collet. So that was an extra step that you don't necessarily have to do on the lathe. Next step, I think what I got to do is drill, because that won't cause a burr. If I face this side, it's going to put a little burr on the edge, and I won't be able to flip it over to face it to final size all the parts. So what I'm going to do is I'm going to drill it first, and then I'm going to face all the parts on one side, and hopefully that'll clean up the burrs on the thing. But you know, with this material, I don't have any high hopes. It's like Play-Doh. So I'll probably have to deburr the one side, then flip it over and face it to final size, and then probably deburr all again. So I had to do that on the lathe as well, but I didn't have as many steps because getting it to length, when I cut it off, it was to length because that's how I did it. So this may not be the most efficient approach I've chosen here. It was just trying to find another possible solution that would be faster. In this case, it may not be. So with this quick change item here, I can throw the part in and lock it down, and it's nice in place. So the one thing I want to do is I want to drill a 5/16 hole down the center of this, and hopefully that'll prevent a burr on the bottom as the drill exits. Also, if you're not pushing really hard, the burr will be less significant. We'll see what we can do here. So there's not a lot of space here, and I could move everything down and use a standard drill chuck, but I'm thinking maybe what I want to use is a collet to hold this instead. Hold the drill bit in a collet, then I don't need anywhere near as much space. So what I've done is I chose to put the 5/32 drill bit in a R8 collet rather than like an ER32 or an ER40, which would grab it better. But since my depth doesn't matter, I don't think I have to worry about that because we're drilling through every part. So if I was concerned about the drill bit pushing up, I would not use the R8 collet. By the way, this is a brand new drill bit. It doesn't have any burrs on the shank. That's important, or it won't hold center and it won't hold well. So this is a brand new drill bit. And first thing we're going to do is we're going to pre-drill into the aluminum stop plate for this so that when the drill goes through, I'll be able to tell. Otherwise, if it's just into material, I won't be able to tell. First step is to pre-drill that, and rather than blow all of the stuff off, a vacuum cleaner to suck the debris away makes more sense, I think. All right, so we're gonna see how long it takes to drill one of these. Okay, I don't know if you can see the focus here, but that destroyed my drill bit. It was at 1,000 RPM, which I thought might be kind of high, but I looked up on a feed table and that seemed right, but it's not. I don't think I've ever seen this happen before, but it didn't break the end of the drill bit. It just wore it off or melted it. I saw it glowing red and immediately stopped. That just ruined the drill bit. And of course the part will be unusable. It just worked hard, and I don't know if you can see this because there's a little conical shaped bit in there. I'm gonna try it again at 700 RPM instead of 1,000, which is where a drill chart I had said it should be. It's just destroying my drill bits. Maybe we need a much lower RPM. The drill chart shows this, but shows about 1,000 RPM for this size drill bit, even into hard machining stainless, but this ain't working. Look what it does to the drill bit end. That was a sharp drill bit, a brand new one. Cobalt, no less. Now I got a carbide drill bit, one size down. It's designed for cooling through, which I don't have, but I should be able to. Well, that cut through. Boy, that was miserable. Let's try it on a new one here. That was miserable, holy cow. I was applying constant pressure and then pulling up fast, still shattered my carbide drill bit. This is a much stiffer setup too. And I was going slow RPM, I was going 200 RPM this time and broke it. I think higher RPM is probably better, but I was having problems with chip welding at higher RPMs. This is a coated drill bit and I was still getting chip welding on it. So honestly, I don't know what the solution is with this 321 stainless. This stuff sucks. Well, I might have found a combination that works. Slow speed, like 200 RPM, and high speed steel because carbide's too brittle. And as a coolant, I was using my cutting fluid, but I'm going to try alcohol. Which not only makes less of a mess, seems to be working. Well, seems to work. I think the cutting fluid might work a little bit better, but it smokes a great deal, which kind of sucks. It makes a huge mess. So I'm going to try and stick with the alcohol for now. It's using quite a bit of alcohol, but it is keeping the drill bit cool enough that it's probably keeping it from its plastic temperature. The first drill bit I chose at 1000 RPM actually started glowing red. Did you hear that little snapping sound? That was a burr turned up in the bottom of this hole that the drill bit caught on. When I have carbide drill bits and that happens, snaps the carbide drill bit every time. So I've got the drill doctor out because every 4 or 5 parts, I've got to resharpen my drill bit. All that debris there is what's from sharpening, and I've actually cleaned it up twice already. And after you do one cut, you can see how mushy this stuff is. It sticks in the end of it. Now you can pop that out. Usually it takes a scribe to do it, but it's there every single part and you got to pop it out before you do the next part. This stuff's the worst. All right, so we finished most of the pieces. We had a couple losses, not too many. Some of them are not centered really great, which is unfortunate, but fortunately this is going to be bored after, and hopefully they're not off so far that the boring can't correct that. If you want to see how many times I sharpened this drill bit, the one on the right is the one I was using. The one on the left is a new one. You can see how many times I have sharpened this. Is that not insane? Okay, next up, I was originally going to hold these in the mill and take a milling cutter across it, but you can see what it's doing. It's just smearing all over the place. So I think we're going to do it on the lathe because it'll just be more convenient. I thought the mill was going to be a better solution, especially, let's go over here and take a look at this. With the hand wheel, I thought that was going to make it so much easier than constantly moving the whole tailstock in and out. But in reality, it was every bit as hard and other steps were harder. So yeah, half the time I was using 2 hands on this wheel. That's how much pressure was needed. This stuff's amazing. Anyone has any experience with 621 or 321 stainless? Let me know. Easily the worst thing I've ever worked with, worse than Inconel, even though I've never had to drill a bunch of holes in Inconel. Maybe it's worse, but as far as I know, this is the worst thing I've ever done. And it was just non-stop misery. The chips work hardened on the way out, so they're gummy, and then they turn really hard and brittle, and they stick to the drill bit and everything else. Just no fun. All right, well, we're back at the lathe, not by my own volition. It just seems like the best choice. Should have done the whole thing here. Thought the mill would have sped things up, but it's a fail. So we've got two sides of these. One side's rough, but mostly flat, and the other side has the burr from the hole going through it. And so we're gonna cut this guy off first and just clean up this face. We're gonna deburr the outside edge and the inside and face it. And then we'll do another pass with every part reversed where we'll cut them to size, deburr. And well, I was originally gonna take an end mill across these and then deburr them, or hopefully wouldn't need to deburr them much, but seeing as how this material just destroys cutters, I think we're gonna go for this route because inserts are cheaper than end mills, and I think it would destroy the end mill in no time flat, and especially just the bottom where you need it. That is way out of center. That part may be scrap. Which is amazing how out of center it is considering every one of these was center drilled. I've switched to a different insert here because the other inserts were dulling after every couple of cuts, parts, like 3 or 4. This one did not fare a lot better. The first couple parts, it was really sharp and it didn't smear the material all that much. But after just a couple parts, it no longer would not smear the material all over the place. Deburring tools. Trying to deburr that center, which I didn't even get a good deburr here. Had to go back and put it back in. Those deburring tools, I went through every one I had because after 10 or 15 parts with the better deburring tools, they'd be dull and ruined as well. Here we are with the same cutting tool after 4 or 5 parts and smear. And that is probably 8 to 10 hours worth of work. I don't think I'll ever take this job on again. It is not worth it. It destroyed tools left and right. Chamfering tools, drill bits, you name it, carbide inserts. This stuff is really hard on tooling. I couldn't find any combination that was great. The final tool I had on this insert here, this one held up pretty well, although you could tell only the first couple cuts were super sharp and did a clean cut. After that it sort of smeared, but still worked. Unbelievable. Here are just some of the casualties. These are just chamfering tools. These are really crappy ones. These are much better, but still they would dull after 10 or 15 parts. You'd only get a really sharp cut for like the first 2 or 3 parts, and after that it was a lot more effort to get any chamfer out of it all. Anyways, a good learning experience, but not happy. Thanks for watching. Hope you find it useful. Hope to see you next time.